All right, now we get to go on to graphing. First of all, graphing sine and cosine. So I'm just going to get right to it. Here is the basic graph of sine on the x and y axis. So sine starts at the origin. It then goes up to a height of 1 and comes back down. It then goes down to -1 and then comes back up and hits the x-axis. Need to just extend my x-axis a little bit right here. So it actually goes from 0 to 2 pi using radians, the preferred method. It goes from 0 to 2 pi in order to draw one full cycle of sine. It would then repeat and then repeat and then repeat. And it would go in this direction also. It would go down and then up and down and then up and down, and it would go forever. But this right here is called one cycle. And because it goes from 0 to 2 pi, that's called the period. Now, like I said, it goes up to 1. And so from the middle of it, so this would be the x-axis in this case, if you go from the middle to the highest point, that's a height of 1. That is called the amplitude. And whether you measure it from here down, this is still a length of 1, and this is a length of 1. So the amplitude is 1. Now, before we go on to cosine, there's some other information, like if this is 2 pi, then this is right in the middle of 0 and 2 pi, so this is pi. And then this would be in the middle of 0 and pi, so that is half of a pi, which I could eat for breakfast, half of a pi. And then this would be 3 pi over 2, and there's the graph of sine. Now let me just label it y equals sine of x. What about cosine? Well, cosine actually starts at the top. It starts at +1. It then swoops down to -1. And then it makes the return trip back up to 1. And this also goes from 0 to 2 pi. So that means that the period is also 2 pi. And because its height from the middle up to the top is 1, or from the middle to the bottom is 1, that means that the amplitude is equal to 1. So in the middle right here, that would be pi. Where it crosses the x-axis right here, that is pi over 2. And right here where it crosses the x-axis, that's 3 pi over 2. Then let me just label it y equals cosine of x. So those two graphs are so important that, remember my little friend, the 3x5 card? Well, looky here. I even put those on here because we're going to use these a lot. So they're not only used in applications and making pretty graphs, but also later on when we're solving equations, this is really going to help. And then I got some space right here for tangent, but that's the next section. Okay, now, you know what? Before we do that, I want to use the graphing calculator. And we'll do this one. So set the calculator so there isn't too much of a glare. Oh, as you can see, I was balancing my checkbook yesterday. Oh, hold on, this is in polar form. Let me change the mode back to function form. Y equals, there we go. And then just put cosine of x. And then I want the x values to go from 0 to 2 pi. So change the window and have x go from 0 to 2 pi. And then the y values go from -1 to 1. And for the scale, if you want it to be the same as this, then it needs to go by pi over 2. You don't have to do that part, but just so that it looks the same as this, I'm going to do that. Pi divided by 2, and then graph. And then you can see right there is pi over 2, right there's pi, that's 3 pi over 2, and that's the graph of cosine. Now for the next part. So what if you have 3 times sine? So this is going to be the same general shape, but that part's basically saying the y values are equal to 3 times what they used to be equal to. So it should be basically the same graph, except this will go up to 3 and that'll go to -3. So that's my prediction. So it's going to go up to 3, down to -3. Otherwise, it would look the same. So it still looks like sine is just a taller version, or it's been vertically stretched. Sometimes I wish I was vertically stretched another 2 inches or so. And then just label the parts just like this right here. And then use the graphing calculator and see that I got it right. So y equals, clear out this old one, and the new one is 3 sine of x. Now I need to go in and change not these values, but these values. So the window 0 to 2 pi is fine. Then for the y values, go from -3 to +3. And then it's drawing this right here. So when you go to graph these, and especially as they become more complicated / interesting, then whatever you have right here as your x values and your y values, then you should put the same thing when you do the window. So 0 to 2 pi, and then -3 to 3. So that way, you're just looking at that window right there on the calculator, instead of if I did something like this, hey, have it go from -10 to 10, and have it go from -10 to 10. And then it's going to look like this, and I'm wondering, wait, is that the same as this? Well, I really need to zoom in. And instead of having to do that, just make the window the same as this. Okay, so for this one, the period is 2 pi, and the amplitude, and after a while, we'll start abbreviating these as just PER and AMP instead of having to write out the whole thing. And the amplitude is 3. So I can't emphasize enough. Amplitude is not going from the very bottom to the very top, but it's saying from the middle to the top, how tall is it? So basically, how tall is this hump right here? Or what's the length of this one? They both have a length of 3. That's the amplitude. Hey, I've got a little space right here. I think I could do example number 2. How about y equals negative cosine of x? So now this is saying that the y values equal negative of what they used to. So for example, right here, the y value is a -1. So this is going to get flipped up to +1, and this is going to get flipped down to -1. So basically, it's going to take that shape and make it look like that. It's going to flip it upside down. So, like always, I'm going to draw it myself, and then I'm going to use the graphing calculator to see if I got it right. So this one, instead of starting at the top and going down, it should start at the bottom and then go up. And the number in front of this is a 1. So it's going to go at the very tallest to 1 and the lowest to -1. Right here is the 2 pi. in the middle is pi. This x-intercept is pi over 2. And right here is 3 pi over 2. And then graph it and see that I got it right. So negative cosine of x. Change the window to be the same as this. From 0 to 2 pi, and from -1 to +1. And then it's drawing this upside down cosine graph. Yay! Good job, calculator, you're doing a good job. Okay, now on to the next idea. So for example number 3, y equals sine, and now what if we put a 2 in there with the x? So that's going to change the x-axis. So usually the x-axis would go from 0 to 2 pi. But this is actually changing the x values. Notice that the y values are not going to be changed because it says y equals just a 1 times sine. So that means that it's going to go from +1 to -1 on the y-axis. But what happens to the x-axis? So instead of going from 0 to 2 pi, does that make it go from 0 to 4 pi? Je ne sais quoi. Vamos a ver. So what if you have y equals sine, I need to clear out the old one, sine of 2x. And suppose that we leave the window the same as this. So from 0 to 2 pi, that could stay the same. From -1 to 1, that sounds good. Then what does that 2 on the 2x do? So it drew it once, and now it's drawing it twice. So from 0 to 2 pi, it's now going to draw it twice. If I only want one cycle, that means I need to cut half of the graph off. So it should actually now go from 0 to pi. And if I put it going from 0 to pi, then it just draws the graph one time. So this one would go, so it would look like the sine graph. And it's going to draw, so I'm just drawing one cycle of it. And then this right here would be pi instead of 2 pi, which means this right here is pi over 2, is half of it. And then this would be even half of that. That's 1/4 of pi. And this would be 3/4 of pi. So that means that on this one, the period, I just said I was going to abbreviate it and then I didn't do it. Okay, next time. The period is, it goes from 0 to pi, so the period is pi, and the amplitude is equal to 1. So in general, when you have a number right there in front of the x, the period of the function is going to be 2 pi divided by that number. And then in here, the 2's will cancel, so the period is pi. Then for example number 4, how about if y equals cosine of 1/2 x? So the number sitting in front of cosine is a 1, so that means that the amplitude is equal to 1. Then the period would be, now I'm going to use this idea. So for cosine, the original period would be 2 pi. If this was just an x, that would just be a 2 pi. But now that it has this 1/2, you need to divide by 1/2. which means when you divide by a fraction, you invert and multiply. So that means it's going to be 4 pi. So it's going to take all the way from 0 to 4 pi to draw the graph once. From 0 to 4 pi, and then draw the graph once. The amplitude is 1, so on the y-axis it's going to go from -1 to +1. And then just draw the cosine graph. So right now I'm just looking at the shape. I'm not looking at pi over 2 and all of that, because this one is different, but the shape is cosine starts at the top. It then swoops down to the bottom and then returns back up to the top. So this right here would be half of that. That would be 2 pi. That means it's crossing the x-axis at pi. And this would be 1 pi, 2 pi. This would be 3 pi. All right, now I want to see that I got it right. Notice how I'm not saying if I got it right. My positive attitude is saying I got it right. I want to see if the calculator can get it right. Okay, so here's the function. And again, I need to change the window to look like this. So it's going to go from 0 to 4 pi. And then these are pi's, multiples of pi. So I'm going to change the scale to be pi. And then the y values from -1 to 1, that should do it. So then the graph should look just like mine. Good job, calculator. It crosses the x-axis at the right point, crosses the x-axis the second time at the right point, and there it is. And I can even double check that this point is correct by going trace and put 3 pi. Yep, 3 pi, that's where it's crossing the x-axis. Okay, so in summary, so if you have y equals a times sine and then b times x, or if you have y equals a times cosine bx, then this number in front is telling you the amplitude. Now, the number in front could be positive or could be negative. When it's negative, that's when it flips the graph. Like if this said negative in front of the cosine, then the graph would have looked like that instead. That's what a negative would do. And negative is not a part of the amplitude. So take the absolute value, and that's going to be the amplitude. And then for the period, that would be 2 pi. And then you divide by whatever number this is. All right, then put those ideas together for example number 5. So I was saying graph 1 cycle, but I guess I should also write that out. Graph 1 cycle of y equals 5 cosine pi x. So how much is the amplitude? Yes, you're right, it's 5. And in the period, you use the formula 2 pi divided by whatever number is sitting in front of x. So in this case, it's going to be 2 pi divided by pi. And then, just like when I have a fork, the pi disappears. So the period is 2. So on the x-axis, it's going to go from 0 to 2. On the y-axis, up to 5, down to -5. And this one is the regular cosine graph, which starts at the top. By the time you're in the middle of the graph, it's down at the bottom, and then it goes back up to the top. I think it should have been continued till it's right above the 2. Perfect. And then this would be 1 right here, which means this is a half. and this is 1.5 or 3/2. One more time, check on the calculator. Y equals 5 cosine of pi x. And then change the window to look just like this. Go from 0 to 2, and these are going by 1/2 on the x-axis, so go by 1/2. And then the y values from -5 to +5. And then we should see the graph looking just like this. Although that one's blue, this one's red. That's okay, I could fix that, watch. Change the color to red. There we go, now it looks just like mine. Ta-da! All right, then there's one more application. Number 6. So suppose that you have a store and you sell skis. Well, during the winter and right up before the winter, you're going to have a lot of sales. In the middle of summer, not a lot. So that's what this idea is based on. So the sales of a seasonal product are given by sales at time t are equal to 58 plus 32 cosine pi over 6t. And then t equals 0 represents January 1st of any given year. Then part A, find the period and the amplitude. So the amplitude, that's the number that's sitting right here and multiplying. So that is 32. The period would be 2 pi divided by pi over 6. Which means we need to invert and multiply. So multiply by the reciprocal, 6 over pi. And then, as you can see, thanks to the red pen, the pi's get canceled. So the period is equal to 12, and that is a month, so it's 12 months. Then I threw in something extra, which is actually a part of the next section, but that's okay, you could have it for free right now. The whole graph is going to get shifted up by 58. So that means that originally the amplitude being 32 means it goes from -32 to +32. But then this says add 58 to that. So that means that this has to be shifted up. So add 58. This has to be shifted up, add 58. So this is like my little scratch work over here, scratch paper. So let's see, how much is, calculator, wake up. So how much is 58 minus 32 and 58 plus 32? So it's going to go from 26 to 90. So 26 to 90. And then also whatever number this is, that's what's in the middle right here, 58. Because basically it's going 58 plus 32, so 58 plus 32 is 90, and then 58 minus 32 is 26. And this is going out from 0 to 12 months. And what do we have? Cosine. So we have cosine going like this. And since right here this is going from 0 to 12, that means that right in the middle would be 6. And that was actually my question B. When are sales the lowest? So that would be right here in month 6. So the answer is when t equals 6. And then the other part that's interesting is, what month is t equals 6? So usually we would call that June. But then again, right here it says to use 0 for January. And we don't usually use 0 for January, we usually use 1. So we'd have 0, 1, 2, 3, 4, 5, and then 6. So this would be January, February, March, April, May, June. This is actually July. So that would actually be the very first day of July. Since this is 6.0, that means that it would be July 1st.